In this unit, we're going to explore the exciting world of sequences and series. However, today we're only going to be looking at sequences, and then we're going to focus on one specific kind by the time we're done. First of all, a sequence is just a set of numbers written in a specific order. So, for instance, 2, 4, 8, 16, 32, ... And typically there's a pattern to them. Okay? Now, the notation that we're going to use looks like this. And these are all subscripts. So a sub 1, a sub 2, a sub 3, ... a sub n minus 1, and a sub n. Okay? But the number one question I get from this is, what does that mean? Okay? So, breaking it down, a sub 1 is the first number in the list. A sub 2 is the second number in the list. A sub 3 is the third number, and so on, until we get all the way down to the nth term in the list, which is just the last number in the list. If we should have a sub n minus 1, okay, what this is just meaning is this is the number to the left of n. That's all. Well, of the nth term. So it's the next to last one. All right, so for instance, what we're going to be looking at first is something called recursive form. You've looked at this before. It's just been a while. And it's a form that uses the previous term to determine the next one. So once you know the pattern, you could just add, subtract, multiply, or divide to get to the next number. Okay. So what we have to do is we have to know the first number, okay, the first term. Then we're going to state the rule to get all of the other terms if we're going to be asked to write a recursive rule. Okay, so here we go. So if a sub 1 equals 3 and a sub n equals 2 times a sub n minus 1, then find a sub 2 and a sub 3. All right, what this is saying is, if this is the first number, to get the next number, which is a sub n, they want us to do 2 times the number to the left of it in the list. Well, you're probably saying, there is no list. Well, 3 is the first number in the list. So to get the next number, they want me to do 2 times the number to the left. So a sub 2 is 2 times the number to the left. This is the second position. So that's a sub 2. That's where it's going to go. So 2 times the number to the left. So 2 times 3, that's 6. Pretty simple, it seems. Okay? But the notation is really the only thing that throws people off. It's not the idea, it's the notation. So to get a sub 3, to get the third number in the list, I look at the number to the left and do 2 times that number. So 2 times 6 is 12. Okay, not too bad. All right, so now I want to find the first 4 terms of a sequence if I know that a sub 1 is 4, and my next number, to get the next number, I want to do 3 times the number to the left plus 2 more. All right, so I want the first 4 terms. So 1, 2, 3, 4. You don't have to make the dashes. That's just something I do to help me keep things straight. This is a sub 2, a sub 3, a sub 4. And the only reason I'm putting the ND, RD, and TH down here so that I remember that it's not a fraction. That's all it is. Okay, so the first number is 4. To get the next term, I need to do 3 times the number to the left plus 2. Well, 3 times 4 is 12, plus 2 is 14. So that's my second term. To get my third term, I'm going to do 3 times 14 plus 2. Well, 3 times 14, that's 42, plus 2 is 44. To get a sub 4, I'm going to do 3 times 44 plus 2. And that gives me 134. And those are the first 4 numbers in my list. All right, so turn to the page here. Now, if I want to find the first 3 terms of this list, okay, that's pretty common stuff, but then they want me to find the 1,000th term. So here we go. So, 5 is the first number, blank, blank, and then dot, 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 and then they want the 1,000th one. Okay? Well, a sub 2 is 2 times 5 plus 4. So that's 14. A sub 3 is 2 times the number to the left plus 4. Okay. So 2 times 14 is 28, plus 4 is 32. All right, not so bad. But in order to get the 1,000th term, what I'm going to have to do is I'm going to have to do the number in front of it, okay, which is a sub 999 times 2, and then plus 4. And you know what? I'm not feeling that. I'm not feeling that at all. Because that would mean I'd have to find the 998th term, 997th term, 996th term, and there's no way. Okay, that is not conducive to solving anything. So what we're going to do is we're going to use a different form. Okay, so recursive form does not always make sense to use. All right, so what we're going to do is we're going to learn about something called explicit form. Okay, and that's a form that works just like a formula. Okay, where n is substituted to find the nth term. So, for instance, if I want to find the first 3 terms and the 10th term of each of these sequences here, all I'd have to do is put in 1, then 2, then 3, and then ultimately 10. So, first term, so 2 times 1 plus 1. To get the second one, it's 2 times 2 plus 1. To get the third, it's 2 times 3 plus 1. So not bad. So 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And to get the 10th term, I'm going to do 2 times 10 plus 1, which is 21. That's not bad. Okay, that's just a matter of maybe having a little bit of help with the calculation on a calculator. Not too bad. Now, sometimes, however, we get some more complicated displays. Now, this is where having a calculator is going to be handy. And using the parentheses exactly as you see it is imperative. Okay, so -1 to the first times 1 to the second will be the first number. -1 to the second times 2 to the second will be our second term. -1 to the third times 3 to the second. And then lastly, because they want the 10th term, we're going to do -1 to the 10th times 10 to the second. Now, it seems pretty complicated, but with a calculator, it'll be fine. So negative 1 to the first is negative 1. 1 squared is 1. So negative 1 times 1 is negative 1. No big deal. Negative 1 squared is positive 1. 2 squared is 4. So 1 times 4 is 4. So far, so good. Negative 1 cubed is negative 1 times 3 squared. 3 squared is 9. Negative 1 times 9 is negative 9. So far we have negative 1, 4, and negative 9. Okay. And then to get the 10th term, negative 1 to the 10th is positive 1. 10 squared is 100. So 1 times 100 is 100. Now, no, I do not expect anyone to necessarily do these in their head, but if you can do so, you're welcome to it. All right? But do feel free to use a calculator, but please, please, please use those parentheses. Okay, if you don't use the parentheses, you're going to get an incorrect sign answer. Okay? Now, that's just using the explicit form. One of the things that we're going to have to be able to do is take a list of numbers and write an explicit form equation. Now I can look one of a couple different ways, but there's a generic formula that we're going to go through, and we're going to baby step to it. Okay? So the first thing is, how do you write an explicit equation given the first several terms? Well, the first thing is we have to determine which kind of equation we're dealing with. What kind of sequence are we dealing with? Okay, are we dealing with arithmetic or are we dealing with geometric? Okay, you determine that by saying, what do you have to do to go from one number to the next? Okay. Step 2, if it is arithmetic, what is the common difference? Okay, so in other words, what do you have to add or subtract to get to the next number? And then lastly, because you are actually sometimes asked to find this given other information, okay, they want you to determine the first term. Okay, once you have that information, then we can plug it into this formula, where a sub n equals a sub 1 plus, this should be n minus 1, times d. Okay, where a sub n is whatever number in the list that you want it to be. A sub 1 is going to be the first term in the list. N is the number of terms in the list. And d is the common difference. Okay, so let's work through a couple of these. All right? Okay, so first things first. We got a couple very simple ones where they tell us the difference, they tell us the first term, and all we got to do is fill it in. Okay, so here's our generic formula again: a sub n equals a sub 1 plus d times n minus 1. Now, depending on where you look, some people may place the symbol for the difference, okay, after this parenthesis. It doesn't matter. Okay, ultimately, we'll adjust things. Okay, so here we go. They tell us d is negative 2, a sub 1 is 2, so a sub n equals a sub 1 plus negative 2 times n minus 1. You are welcome